right, welcome back, everybody. So today we're going to go ahead and get started right away with some new notes. I think you'll find this unit to be a little bit easier, a nice little warm up coming back to second semester. So our learning target today, we want to be able to evaluate operations on functions given a table, graph, or equation. We want to be able to evaluate a function given a table, graph, or equation. So we're actually going to start with the evaluating portion. And you guys have actually seen this before in Algebra 1. It's a little bit of a review. So we're going to start with some equations here. I've got q of x equals 3x squared plus 5, and I want to find f of negative 2. So what that's really asking me to do is it's saying, right, so function notation, oh, whoops, I want q of negative 2. That's not written properly. So this is saying find the value of q of x when x is negative 2. So just put negative 2 in for x and see what we get out. So we're going to do q of negative 2 equals 3 times negative 2 squared plus 5. So q of negative 2 is equal to 3 times negative 2 squared is 4. And so q of negative 2 is 17. 12 plus 5 is 17. And then we can go the other way around. Right, so I can give you a function r of x equals 4x minus 10. And this time I'm asking you to find x, and I'm giving you r of x, which is we commonly think of as y. Okay, so I'm saying y is 6. Tell me what x is. So we're going to put in 6 for r of x. So replace all of r of x with 6. And then we're just going to solve this equation for x. Add 10 to both sides. 16 equals 4x. We divide by 4, so x should be 4. And hopefully that was something you've seen before. It's kind of familiar to you. We have definitely evaluated functions, if not this unit or this year. We've definitely done it in Algebra 1. So now we're going to go ahead and apply that to some tables and some graphs, and we're going to do operations with them. So the first three are just the basic, just like how do you use a table to evaluate a function, okay? And so that's just a recall, right? If I ask you to find f of negative 1, I'm saying that x equals negative 1. What's f of x, right? So I'm going to go to where x is negative 1 in the table, so here's negative 1 in the table, and then I'm going to go and find the output for f of x. So the output for f of x happens to be 2, so the answer here is 2. Okay, so here, number 2, x equals 0. My question is, what's g of x? Right? So I'm going to go to erase this so that I'm starting fresh here. I'm going to go where x is 0. And this time I'm going to go all the way over to the output for g of x. So g of x is 8. I'm going to go ahead and pause the video, give yourself a minute to try h of 1, see if you're getting the hang of this. Okay, h of 1, we're going to where x is 1, and all the way to the output for h, you should have gotten negative 5. Okay, and we're going to step it up a notch, right? So we're still using this same table here, but now we're adding a little bit to it. So now I'm going to add some operations. So here I'm taking f plus g of 1. And so in order to do this operation, I like to kind of split it up. I'm going to write this as f of 1 plus g of 1. And we know how to evaluate for f of 1, and we know how to evaluate for g of 1. So we're going to find f of 1 first. So go to where x is 1 in the table. Find the output, it's negative 4. Then find g of 1. So go to the output for 1. Go to the g function. The output's 3. And so we get negative 1 as a result. Number 5 is g times h of 3. So here we're going to do g of 3, and we're going to multiply that by h of 3, right? So we got to find first g of 3. So go to where x is 3, find the output for g of 3. That's negative 2. Then we're going to go to where x is 3, and this time we're going to the output for h of x, and that's 4. So my final answer is negative 8. And then I can do f divided by g of 0, right? So this is kind of tricky, right? Because we think, oh, wait, we can't divide by 0. But we're not dividing by 0, we're dividing by g of 0. And so we have to know first what that actually is, right? So I'm going to rewrite this as f of 0 divided by g of 0. Okay, again, g of 0 could be 0. The output could be 0 there, but it doesn't have to be. Okay, so I'm going to go to my table. I want to find f of 0. So go to 0. The output for f is -2. So the numerator here is -2. And then g of 0, so the output for g of x is 8. Okay, not 0. And then -2 divided by 8 is -1/4. So my answer here is -1/4. And then we can make this a little more complicated by adding 3 variables in. It's really no different, though. So if I add 3 variables, and I'm going to skip 7 and 8, I'm going to let you guys do those on your own. I'll come back and give you some answers in a little bit. F plus g minus h of -2, right? I'm just going to go ahead and split this up. So I'm going to make sure that I'm taking each of these functions is being evaluated for -2. So this is going to be f of -2 plus g of -2 minus h of -2. And I'm going to split it up one piece at a time. So let's start with f of -2. So go to my table. X is -2 here. The output for f of -2 is 3. So I'm going to write 3 here. Plus, now g of -2. So I want to go to the output for g is 4. So I'm going to add 4 to that. And then I want to subtract whatever h of -2 is. The output for h of -2 happens to be -8. So I'm subtracting a -8 here. Signs are really important. Make sure you're paying attention to those. So this is 3 plus 4 minus a -8 is really like saying plus. Okay, so 7 plus 8, my final answer should be 15. Okay, I'm going to let you guys go ahead and pause the video for a minute and see if you can evaluate for number 7 and 8. So when I evaluated h of 5, I got -8, g of 5, I got -6, so this is -8 minus -6. I'm getting -2 as an output. Number 8, when I evaluated h of 3, I get 4, and f of 3, you get 0. So this is 4 divided by 0. This actually is undefined because we can't divide by 0. Okay, so that's if I'm evaluating with the table. And then the trickiest one, and it's not even that tricky, but I think it gets a little bit harder and a little bit more confusing, we're going to evaluate given a graph. So we've got equations, tables, and then graphs. Okay, so in this one, now we're thinking the same exact thing, right? So when I look at these functions, j of x, k of x, and m of x, right? So those are just fancy function notation for saying y. Okay, so this is saying x is -2. What's j of x? Okay, and now you can think of j of x as the y value for that particular graph, right? So I'm going to go to the graph for j of x. I'm going to go to where I have an input that x is -2. So x is -2 right here. I need to slide down to my table, my actual, to where I meet the graph, the function. And then I'm asking what is the y value there. So when I go and scroll over, the y value happens to also be -2. So the output for when x is -2, the output is -2. We're going to see that happens for a couple of them. I'm going to actually skip 11. I'm going to go to number 12 because I want you to see when you get an output that isn't the same as the input. So number 12 says find m of -5. All right, so the question is, now the x value is -5. I want to know what's m of x. Right, so I'm going to go on the m function, m of x function. I'm going to go to where x is -5. So here's where x is -5. I want to scroll down. Here's the actual place where I meet the graph, right? Okay, and so the question is, what is the y coordinate of this point? Well, if I go over, the y coordinate of this point is -3. So m of -5 is -3. And then number 13 makes it a little more complicated, but again, you just break it up into pieces, right? So this isn't that much more challenging. I'm just kind of thinking about this as m of 0 plus k of 0. So we're going to find m of 0 first, which I would have done I would have done k of 0 in number 11. Okay, so m of 0, I'm going to where on the m graph, where x is 0, so x is 0 right on the y-axis, and then I want to find where does that actually meet the line, that function. It meets at 0, -1. So my height, my y value, when x is 0, is -1. So m of 0 is -1. Plus, I want to go find k of 0. So I go to the k graph, k of x graph. When x is 0, this is where I happen to meet my function. So when x is 0, y also happens to be 0. So m of 0 plus k of 0 is -1 plus 0, which is just -1. Let's try 14 and 15. So 14 is finding j of -2 and then subtracting k of -2 from it. So let's go, we already know j of -2, we found that earlier, right? So j of -2 we found was -2, so that's easy, we can just use that. And then minus, now I want to find k of -2. So k of -2, I'm going to go to my k function, right, k of x. X is -2 right here. I want to scroll to see where I meet the function. And then that height, I'm going to find the height of this point. So the height of this point happens to be a y value of 4. So k of -2 is 4. So if I evaluate j of minus k of -2, that's going to be -2 minus 4, which is -6. Okay, I'm going to actually let you guys go ahead and pause the video, see if you can figure out number 15 before I go through it. So pause it, see if you can find m divided by k of 0. All right, hopefully you split this into m of 0 divided by k of 0. And we already evaluated both m of 0 and k of 0, right? We did this work up here. So m of 0 was -1. So this is -1. K of 0 was 0. So this is -1 divided by 0. We saw this example earlier. When you divide by 0, your expression is undefined. All right, that's it for our part 1 notes. Actually, we'll go through number 16. We have a little bit of time. May as well, right? So j of -7 plus k of 1 plus m of -5. Okay, so we're going to find j of -7 first. Okay, if you want to pause the video and see if you can do this on your own, that'd be awesome. Okay, j of -7, I go to my j function. So here's j of x. When x is -7, it looks like here's x is -7. Here's where I meet the graph. It looks like I'm getting an output of 0 for j of -7. So this will be 0 plus. Okay, now I want to go to my k function. I want to find k of 1. So I'm going to go to x is 1, scroll up to meet the graph. It looks like the output there, my y value at that point, happens to also be 1. And then m of -5, we already found m of -5 earlier, right? So m of -5 we had as -3. So this is plus -3. And so 0 plus 1 plus -3 gives me -2. All right, now it's time to go ahead and start your practice.